Alright, today I'm going to talk about refraction. Some conceptual ways to understand refraction. I know there's a lot of ways to memorize this. I don't like it. I feel like whenever you're in like a big test or anything like that, it's really easy to forget that. So I'm going to go through some more conceptual ways to think about that. So let's say, by the way, if light in different mediums is confusing to you, I'm not going to spend a whole lot of time on that right now. I have another video you can watch on that, so I'll let you do that. But let's say I have two different mediums here. Let's say this one has, then it's a refraction of 1. So like air has an index fraction of like 1.003. It's very close to 1 because it's really not dense, essentially is what we're looking at here. And let's say I'm entering a denser medium, an index fraction of 2. I don't know what has an index fraction of 2. Really doesn't matter. I just want to show the difference here. So if I have light coming in, if light was to come in straight down through this, right? Assuming no reflection for a second, light's going to continue through exactly how it came, and it would slow down. Of course, I talked about that in another video, and I recommend you watch that one first. However, it would keep going in the same way. Now, when it starts getting a bit tricky is when it starts coming in at an angle and can go into the other medium. So if this was like a perfect reflector, let's say like a perfect mirror or something, it's going to go off and reflect the exact same angle. Now when I say angle, I mean to the normal. Normal meaning to the perpendicular to that surface. So this angle right here, let's say that's 30 degrees. It's not, but let's pretend. That's 30 degrees. That's the angle of incidence. That's the angle of incidence. Okay. Incidence meaning it's incident on that surface at that angle. To the normal is why that's measured. If they say to the horizontal, then go to the horizontal, but angle of incidence, that's what that is. Now, a property of reflection is that it's going to reflect back at the exact same angle. So this angle here has to be 30, and that's just a property of light. Assuming this is a perfect reflector that has an even surface. So not how I drew it here. But, sorry. Let's look at more at refraction. So reflection is going to happen. Reflection is going to happen most of the time. In problems, they could say it doesn't for the sake of argument, but we're going to say it happens here. Now let's say I have light coming in, and let's say this light comes. You know, I'm going to use different color because I'm bored. Let's say the light comes in here. Okay, and let's say that this is an angle here, an angle of incidence, remember, of 30 degrees. Okay, let's just say, I know it's not 30, it's probably closer to 45. Now, the question is, how is it going to bend? It's not going to keep going straight. It's not going to keep going exactly straight through this next medium because it's a different density. Light is electromagnetic. It will bend in a denser medium. So I'm sure a lot of you guys, if you've taken a physics class, have memorized or have been taught that, okay, well, the angle of refraction, or the actual bending of light, if you're going from a less dense to a more dense medium, will get smaller. So let's say this one's now 15 or something. There's a way to calculate that. We could do it, but for the sake of time, I don't want to right now. It would bend in, and that's true, but I want to talk about a conceptual way to know this. You'll never have to memorize this again. It's really nice, actually. So I'm going to ignore the angle for a second. Okay. Let's say this light here is coming in. Alright. And I know that it's a denser medium that it's going to enter. But let's say I forgot. How does it bend closer to the normal? Does it go outside of the normal? I don't know. I don't like memorizing things. Okay. What I'm going to do is I'm going to pretend that light, in this case, is a particle. I'm going to draw like tiny packets of light. Okay, little cubes like this. Okay. Now the important thing is you have to draw the cube like with the ray you're drawing. So if I'm drawing a ray down, I have to draw the cube like this, right? If I'm drawing it like at this angle here, like we're doing here, I have to draw it like that. So the light ray is incident on it, directly perpendicular to it. Otherwise, it totally ruins the analogy. So that's going to look more like this. Okay. Does that make sense? I shouldn't ask rhetorical questions on this. So now looking at it, which corner is going to hit first? Okay. Now the reason I ask you that is pretend that this is like the asphalt up here, and then you're driving onto, I don't know, mud or something sticky or whatever, like in your car, clay or something. When this corner hits first, okay, it's going to hit this denser, this mud, let's say, or this sticky surface, whatever it is, okay? Now when that happens, this wheel of your car is going to slow down, obviously. This one up here, though, that's still on the asphalt, it's going to keep going the same speed. So what's going to happen is you're going to end up curving in, right? So when this actually curves in, your light now looks more like that cube. Instead of being this angle, it's going to be more of like this angle. So not perfectly up and down. I kind of do that perfectly up and down. It's not going to bend that hard, but it will bend maybe more like this or something. So you see how that's more straight up and down vertical than this one was. So this wheel kept going. Now imagine in your car, and this tire here hits the mud. Okay, so you can imagine how the other side of your car is going to swing out to meet this side and keep going faster. This is a property that's true with lenses, light, mirrors, and things like that, and we'll talk about that when we get there. But this helps me to remember this. So as this goes in, remember this light keeps going perpendicular just like that. So if you look at what just happened, if this angle here was 25 degrees, okay, this one definitely looks smaller, right? Whatever it is. There's ways to calculate that. We could do it. I don't want to right now. So it does go in. And so that is a really good conceptual way to do that. So it might take a little bit of practice, but it's pretty intuitive, which means, for me, means you really don't have to do much memorization, and I like that. So I hope that you guys find it just as useful. Now let's flip this, though. Let's say that and it's a refraction of the outside. Let's call it 3. So it's pretty dense here, and this one's 1. Okay, so it doesn't matter. It's just denser on the outside here than on the inside. So when light comes in this way again, which way is it going to bend? So once again, you could try to memorize, okay, well, it should have been outwards because it's going into a less dense medium, and that's fine. But once again, the more conceptual way, I'm going to draw my little cube here. So once again, that same tire of my car, that same corner of the cube of light hit first, right? This one here. But this time I'm going from the mud, like say this is the mud here, I'm going to the asphalt, okay? So what's going to happen is this tire then would logically speed up as it hits the asphalt. It has more friction, more traction, right? So this one's actually going to speed up and start going a little faster. This one here, on the other hand, is going to keep going slow. So what's going to end up happening is your cube's going to turn more like this, for example. Okay, so I'll draw it closer to this. So you can imagine that, right? This one's going a little faster now. It's going to pick up more ground here, and that one's still going slow until it hits that when they go the same speed. So if I erase my little drawing there, what did I end up getting? I ended up getting that, and then it bends away from the normal. So yeah, you can memorize this is the less dense thing, this is the more dense thing, so it's going to bend outwards, and that's fine, that's good. However, this conceptual is going to help us a lot with lenses. Lenses are an interesting thing. Most people know what a converging lens would do in the air, but what happens if I put it under some denser liquid than the lens? My converging lens, is it still converging light? No, I won't answer that right now. We'll talk about that. But if you just memorize, it's going, oh yeah, it's going to bend this way or that way, you're going to be in a heck of a lot of trouble when that kind of thing comes up. So let's think about that as conceptually as possible. Okay, so this is refraction. It's the bending of light because it's not going in the exact same direction as it was, right? That would be as it was continuing. So if I were to draw that picture, there's my angle of refraction. There's my angle of reflection, or of incidence, and then it would end up reflecting at the exact same. So that's the angle. I'm going to call this here the angle of reflection, which would be exactly the same as the angle of incidence, which would both be, in this case, smaller than the angle of refraction because of the bending. So you see how those questions on multiple choice test or something like the MCAT, for example, could get a little bit tricky without the explanation first. So that's refraction, and that's light. Now it's important to understand that once this light enters the old medium again, it's going to bend back to the exact same angle it was at before. Let's say I have it like this, and it goes back to n equals 3 here. So the same medium. I drew that curve pretty hard, so I'm going to erase that so I can prove the point. So let's say it does bend out a little bit more, okay? But when it hits here, it goes and bends towards the normal again, because I'm going to a denser medium, right? Just like my last example. So now this angle here should be the exact same angle as this angle here. Now I'm not a perfect drawer, so it's not. One important thing to understand though is it's not going to be a continuation. So it's not like if I were to continue this thing on, it wouldn't be that way. It's actually going to be a little bit more to the right as I showed it here, as I drew it. So if I erase these, those aren't a continuation. This line here is not a continuation of this line. It's just at the same angle. So I bent it for good. I mean, it's over here now. It moved over that way. And that's an important principle as well. The angle would be the same. So thanks for watching. This was refraction. We'll talk more about refraction and reflection. We'll talk more about diffraction and dispersion in another video, but thanks for watching.